In today's lecture, we are going to continue with the fundamentals of hyperbola that you have learned in the last lecture. And we will take it from there, we will learn few more fundamentals, we will solve some problems and then we will again re-study asymptotes. Okay. So, can we continue? So, basically for standard hyperbola, we have learned the characteristics, we have set up the center, we fixed it at the origin, then we designed the vertices and then we designed foci and then we derived directrices and based on this we have derived the entire setup of the hyperbola. This is what we have done in the last lecture. So, also here the important thing that you have to remember is the formula of this focal distances. Okay. So, generally when it comes to focal distance, if you do not remember the formula, it may take longer time to evaluate focal distance. So, it is better that you remember the formula. Okay. So, compared to ellipse, only thing is that here the distance is multiplied with minus sign, that is the only difference when it comes to this SP. Okay. So, this is one standard property of hyperbola which we can use in problem solving directly. And when it comes to this difference of distances from two fixed points, it has to be maintained with the, it has to be with in consistence with the properties that we have learned in the last lecture. Okay. So, we will discuss that one more time when we are recapping the properties. So, here for the conjugate hyperbola, these are what we have derived. This is exactly same as the earlier one, but only thing is entire situation, entire data is now mapped onto the y axis, earlier it was mapped on x axis. Okay. So, these are the basics. And now, if we revise all fundamentals, so the first one was that if A and B are two fixed points and if P is a variable point which is moving such that difference of distances of P from two fixed points is always a constant. This gives you hyperbola provided there are these conditions. K must be less than AB. So, what happens if K is equal to AB? What happens if K is greater than AB? This we have seen in the last lecture. So, whenever you are applying this definition, that definition has to be in consistence with our earlier discussion of these three conditions. Okay. And next, here in place of this 1, if minus 1 comes, then it is called as the conjugate hyperbola. This also we have studied in the last lecture. Now, if E1 and E2 are the eccentricities of these two mutual conjugate hyperbolas, then this condition is always satisfied, that 1 by E1 square plus 1 by E2 square is always equal to 1. Okay. So, these we have studied and also we have studied that two mutually conjugate hyperbolas will have the same set of asymptotes. Only thing is that transverse axis and conjugate axis are now reversed. Okay. Next, rectangular hyperbola. What are the basics of rectangular hyperbola? We have learned that angle between any two asymptotes of the hyperbola, angle between two asymptotes of the hyperbola is given as 2 into tan inverse B by A. Now, suppose let us say I have taken these two as the asymptotes. Now, the angle between asymptotes is basically 2 into tan inverse B by A. If this angle is 90 degrees, if this angle is 90 degrees, that means we can say that two asymptotes are at right angles. So, these two asymptotes form a rectangular system there, that is why the hyperbola is called as rectangular hyperbola. So, this is what should come to your mind as first idea when it comes to rectangular hyperbola. Rectangular hyperbola means angle between asymptotes is 90 degrees, that is the first idea. Now, based on this, if I let us say equate this to pi by 2, what happens to A and B? If I equate this to pi by 2, then tan inverse of B by A becomes pi by 4, which means tan of pi by 4 is 1, that means B by A must be equal to 1. So, which means B equal to A. So, when it comes to rectangular hyperbola, the transverse axis and conjugate axis are basically equal. So, that is what our first property is, which says that length of the transverse axis and conjugate axis must be equal for rectangular hyperbola. But idea of rectangular hyperbola must come from the angle between asymptotes. You need to remember this point. Next, the eccentricity of rectangular hyperbola is always root 2. So, this we can derive directly from the idea that A must be equal to B. So, if A is equal to B, if you recall the formula for the eccentricity of hyperbola, what is it? E is equal to root of 1 plus B square by A square. Now, because B and A are equal, we can say that this is equal to root of 1 plus 1, which is same as root 2. So, eccentricity of rectangular hyperbola is always root 2, it is fixed. For general hyperbola, E is a constant which is greater than 1. It can be any constant. But for rectangular hyperbola, E must be root 2 only. Okay. So, this is basic idea, but all of these could be derived from the idea that angle between asymptotes is 90 degrees. Come on, make a note of this. Okay. Can we move on? Okay, next. So, this is the shifted versions of the hyperbola and its conjugate. So, when I subtract h from x and k from y, it means entire setup is shifted h units right and k units up. So, now that means every point also gets shifted. So, when every point shifts, what happens to the coordinates? To x coordinate h gets added, to y coordinate k gets added. So, that way we can derive all these forms on our own. Now, as I keep saying, it is essential that you guys learn to derive them on your own. Only then you will have clarity, and only then you will be able to solve questions on your own in the exam also. Okay. So, you need to derive all of these on your own. Of course, you can take a snapshot and make a notes, but you need to derive all of them on your own. Okay. Next. So, now comes the parametric equations. So, suppose let us say we have this x square by a square minus y square by b square equal to 1 as our standard equation of the hyperbola. So, algebraically I can take x equal to a sec theta, y equal to b tan theta. If I take it, then definitely equation will satisfy. So, algebraically we can say that theta is a parameter, it may vary, and this by applying this idea we are separating x and y into a third parameter which is the theta. So, we can call it as parametric form. But what could be its geometric meaning? So, this diagram will clarify with that geometric meaning. Suppose let us say on auxiliary circle, I have taken a point P dash which is a cos theta b sin, a cos theta a sin theta. Okay. So, on auxiliary circle, let us say I have taken a point which is a cos theta a sin theta. Now, at this point if I draw a tangent, so you see this is the tangent, equation of this tangent will become x cos theta plus y sin theta is equal to a. Equation of the tangent will become x cos theta plus y sin theta is equal to a. Now, here n is the point where this tangent is intersecting x axis. So, suppose let us say I want to find out that n. So, what do I do here? If I put y equal to 0, I will get the point. So, substituting y equal to 0 here, I will get x as a by cos theta which is same as a sec theta comma 0. So, these are basically the coordinates of n. Now, from n if I draw the ordinate, what is the meaning of ordinate? Perpendicular drawn to x axis from any point anywhere. So, here if I complete that ordinate, P is the point where this ordinate cuts the curve. Now, if I am interested in finding the coordinates of P, I just have to substitute a sec theta in the equation and I have to derive y. So, by this method we can get y to be b tan theta. So, that means a sec theta and b tan theta becomes the parametric form, and here theta has a meaning, theta has a significance. So, what is theta here? Theta is the angle made by the corresponding point on the auxiliary circle. So, if that point is making an angle theta, only then we can get a sec theta b tan theta for the point on the hyperbola. So, point on the hyperbola is not definitely making that angle. Okay. So, this is one simple idea. Now, if you also observe the variation of theta. So, if theta belongs to 0 to pi by 2, 0 to 90 degrees, then our point is going to vary, our point on the hyperbola is going to vary in the first quadrant on the first branch of the hyperbola. So, also if I want the other part of the first branch, the angle must vary between minus pi by 2 to 0. So, that means for this right side branch, theta must be belonging to minus pi by 2 to pi by 2. What happens at exactly theta is equal to pi by 2? Then the point is not defined, because tan theta and sec theta are involved. Algebraically we can say that it is not defined, but geometrically there is no point at which theta there is no point at which the curve cuts y axis. So, hence theta equal to pi by 2 does not lead to any point, but theta equal to 0 will give us a point. Okay. So, which is same as the vertex. Similarly, for the other branch, theta must be belonging to pi by 2 to 3 pi by 2. Okay. So, this way we can observe that there are only 2 points where eccentric angle and the original angle are equal. Okay. So, this way we can understand the meaning of parametric form of hyperbola. Now, also there is another point that you can notice. Suppose if I take this point, let us say there is this hyperbola and there is this center of the hyperbola and we have the eccentric circle here. So, here the P dash point is making an angle of theta with the positive x axis, and if let us say P is somewhere here, if P is making an angle of alpha, we can definitely get the relation between theta and alpha. So, because the coordinates of P are a sec theta, b tan theta, if we take the ratio of x coordinate and y coordinate, we get tan alpha is equal to b tan theta divided by a sec theta. This will give us b by a into sin theta. So, this way alpha and theta are directly connected. Okay. So, if you are interested in only finding the angle alpha, you can use this idea to get the alpha. But again I keep saying that you do not have to remember these formulae. So, now the more formulae that you try to remember, the more stress you are going to put on your mind. So, do not remember too many formulae, instead learn to derive them on your own, and as in when the situation comes, your mind will automatically react. Once if you derive all of them, that method and those ideas are registered in your subconscious mind, and when you are solving the problem, mind will automatically decide a way out. Okay. So, this way we can connect alpha and theta. Okay. So, definitely make a note of this. This page also. Now, let us say we have taken the conjugate, which is y square by b square minus x square by a square is equal to 1. So, for this conjugate hyperbola, what could be the parametric form that we could write? We can say that y equal to b sec theta and x equal to a tan theta. Now, here because this is the conjugate one, you can also try to get the meaning of this point by drawing the auxiliary circle and verifying this. Okay. But that I am leaving it to you, because it is better that you derive it on your own. Okay. So, basically here we have understood what is parametric form. Now, the question is this parametric form unique for the hyperbola? No, because this is involving the theta, which is eccentric angle. We use it most of the time, but this is not the unique form. So, as we will see in one of the questions today, that there could be a different parametric form for this hyperbola also, and there could be many such forms. Okay. There is no limitation on such parametric forms. Okay. So, can we move on now? So, now in the notation, this is the standard notation that we have been following since the circles. So, if I take the curve, we generally denote that with S, and for the partial substitution of the point, we denote it with S1, and S1 has degree 1, S has degree 2. So, S equal to 0 will give us a curve, S1 equal to 0 will give us a line. We do not know what is that line, we will see that. Okay. Next, S11 is full substitution of the point. So, this will give us a number. S12 is partial substitution of one point and partial substitution of other point, but this also will give us a number. Okay. So, we have understood this notation in the earlier chapters also, and it is the same notation. Now, when it comes to the location of a point with respect to hyperbola, how do we understand it? So, let us go back to the earlier concepts only. So, earlier I said that if there is any curve y equal to f of x, so any point if it is above the curve, we can write y1 greater than f of x1, and if the point is below the curve, we can write y1 less than f of x1. Now, suppose let us say I use the same idea for the hyperbola, then what happens? Let us say I applied for only one branch of the hyperbola. So, here the equation is x square by a square minus y square by b square equal to 1. So, if I keep only y on one side and take everything else to the LHS, so that means I am taking the y terms here. So, we can write this as x square by a square minus 1. So, above the curve what will happen? Y square by b square will be greater than x square by a square minus 1. Because we are talking about a point, we have to put x1 and y1 here. So, now we can understand that S11 is basically less than 0 here. So, in this region S11 is less than 0. So, that means in this region S11 will be greater than 0. By same logic, we can also say that in this region S11 is still greater than 0. In this region S11 is less than 0. Okay. So, here you notice that there is a square on y. So, that is why whatever is followed here, similarly it will be followed here also. But only thing is direction is reversed because of the squaring. Okay. So, now what is the interior of the hyperbola? Because if you look at the diagram of hyperbola, it does not have any closure. Diagram is not closing anywhere. In fact, this is approaching straight line here and also it is approaching a straight line here. So, there is no closure of the diagram, but still we can define interior region as the locus of all points from where tangents are not possible. For example, here from this region if I take any point, tangent cannot be drawn through that point. For example, even if we have the other branch, from this point we cannot draw tangents to this curve, it is not possible. This I have explained in the last lecture when I was explaining the asymptotes. So, because this is the region from where tangents are not possible, we take this as interior of the hyperbola. So, we can say that if the point is inside the hyperbola, S11 must be greater than 0, and for this region which is between these two branches, we take this as the exterior of the hyperbola. So, for exterior region S11 must be less than 0. Now, what about the points on the curve? Of course, S11 must be equal to 0. So, that is what we have listed here. So, basically if S11 is greater than 0, point is inside, S11 less than 0, point is outside, S11 equal to 0, point lies on the curve. Okay. So, here we have understood what exactly is the interior region, why is it the interior region, and what happens to S11 in the interior region. We have understood that completely. Come on, take a snapshot of this also. Also with this. Okay, next. Now, based on the ideas that we have learned, which are the basic fundamentals of the entire chapter, we will solve some questions. If possible, we will try to cover as many questions as possible. And towards the end, if possible, if we get time, we will also touch asymptotes one more time, but this time with more algebraic clarity. Okay. So, we got already required geometric clarity earlier, but at later stage we will touch the algebraic clarity. Okay. So, let us solve some problems. So, here the lattice rectum subtends right angle at the farther vertex. So, find E, this is the question. So, that means suppose let us say if I take one hyperbola and these two are my vertices. So, let us name this as A, name this as A dash. Now, there is one lattice rectum, I am assuming one lattice rectum here, and what is given? Lattice rectum subtends right angle at the farther vertex. So, which vertex is farther from this lattice rectum? This vertex is farther. So, that means if I join these two, this angle must be 90 degrees. Okay. So, here irrespective of where the location of this hyperbola is, the value of E will not change. So, without loss of generality, we take the standard form which is fixed at the origin. So, that means this point will become a comma 0, this point will become minus a comma 0, and this if I name them as L and L dash. So, L point will become a e comma b square by a, and this point will become a e comma minus b square by a. Because this is subtending right angle here, I can take m1 m2 equal to minus 1, that means product of slopes must be equal to minus 1, or because it is making 90 degrees and because we know that the diagram is already symmetric. So, if I just take the half of this angle, okay, which is the angle made with the positive x axis, that angle must be 45 degrees. So, I can just take height by base equal to tan 45, that way also I can solve it. So, basically here the idea is to get one relation between A and B and then crack E. Okay. So, let us try to solve it by taking any one of these ideas, it does not matter. So, I am just taking height by base. Okay. So, here height is basically b square by a, and the base is going to be distance from this point to this point, because this point is focus which is a comma 0, distance between these two will be a into 1 plus e, and it must be equal to tan 45 which is same as 1. So, here what are we getting? We are getting b square by a square into 1 by 1 plus e is equal to 1. Now, b square by a square can be written as e square minus 1, that is how we defined b square. So, here we can write e square minus 1 by e plus 1 equal to 1. So, e square minus 1 can be factorized as e minus 1 into e plus 1 by e plus 1 equal to 1. Now, we know that value of eccentricity E is always positive irrespective of the curve that you are taking. Okay. So, for ellipse or hyperbola or parabola, E is always a positive number because it is ratio of distances. So, E plus 1 can never be 0, so we can cancel it. See, at every step I keep on make suring the other possibilities also. So, that is what is called as completeness. You should always go for the completeness and perfection, because if you do not have conceptual clarity, you may mess up in multiple answer questions. So, the essential idea to score high in multiple answer questions is to have more and more clarity. So, because we cancelled e plus 1, what remains here is e minus 1 equal to 1. So, which will give us e equal to 2. Okay. So, to this question the answer is e equal to 2. Come on, make a note. Can we move on now to the next problem? Okay, next. If the vertices and end of conjugate axis form an equilateral triangle, find E. So, here also let us take one setup. So, let us say we have one hyperbola here and these 2 points are the vertices. Now, if I take conjugate axis, so this point becomes 0 comma b, this point becomes 0 comma minus b, we name this as b, we name this as b dash, this as a and a dash. Now, it is given that a dash and b form one equilateral triangle. So that means if I join this point B with A dash and also with A, we have to get one equilateral triangle. If this is forming an equilateral triangle, then the other point B dash also will form an equilateral triangle. So if we do it for one, then it means the other is also justified. Due to symmetry, we can say that. Now coming to this, because already this is also on y axis, there is also another symmetry here. Basically there are two axes of symmetry here. So that means if I say this distance is equal to this distance, I do not have to check for the other distance also, because it is already equal. So what I will do here is I will basically apply the simple rule of equilateral triangle, that sides are equal, and from that constraint equation I will generate the value of E. Okay. So how do we do that? If I let us say take this point as a comma 0 and this point becomes minus a comma 0. What is this distance? It is 2a. So 2a must be equal to this distance. Now what is the distance between a and b? It is root of a square plus b square. Now from this relation we can crack the value of E. So if I let us say square it, what do I get? 4a square equal to a square plus b square, which means 3a square equal to b square, which further means b square by a square is equal to 3, but b square by a square is always equal to e square minus 1. So we can take this as e square minus 1, which will give us e square equal to 4, which means e is equal to 2. E cannot be minus 2 for the same reason that we have discussed in the earlier question. So in this question also E is equal to 2. So if you notice, in earlier question also we got E equal to 2, and in this question also we got E equal to 2. So in fact in hyperbola chapter, E equal to 2 and root 2 are two special hyperbolas where most of the questions are touched. Okay. Come on, make a note of this. Okay, next. So here 2 points are given which are foci, and hyperbola passes through a point 0, 0. So basically we have 2 points here. Let us say A is here, which is 5, 12, and there is one more point B here which is 24, 7, and there is one point origin, and in the question it is given that the origin lies on the curve. So that means difference of these two distances must be equal to 2a, and distance between two foci must be equal to 2ae. So if I just take the ratio, I can get the value of E. So how do we do it? Just get these distances. So now this distance becomes root of 5 square plus 12 square. So we know this standard result because 5, 12 and 13 are Pythagoras triplets. We can say that this is equal to 13. Similarly, 7, 24 and 25 are Pythagoras triplets. So we can say that this distance, which is supposed to be root of 7 square plus 24 square, must be equal to 25. Now what is the difference of these two? Difference of 13 and 25 is 12. Basically we are talking about absolute difference. So that 12 must be equal to 2a. So we got one constraint equation. Now by taking the distance between these two, we will get another constraint equation, which is 2ae is equal to root of 24 minus 5 whole square plus 7 minus 12 whole square. So this is going to give us 19 square plus 5 square. Now 19 square is how much? 361. But if you do not remember the value, what is the best way to do it? Best way to do it is to write 19 as 20 minus 1 and then apply a minus b whole square and get the number. Okay. So here it becomes root of 361 plus 25 is going to be 386. Okay. So if I take the ratio of these two, I will get the value of E. So E becomes equal to root of 386 divided by 12. That means we have solved the question. Okay. So this way we can use properties and solve questions. Okay. Come on, make a note of this. Okay. Next, can we proceed? If one focus is 1, 2 and nearest directrix is 3x plus 4y plus 9 equal to 0 and E is equal to 3. Find the other focus and other directrix of the hyperbola. So, here to get the clarity, because here lot of geometry and lot of clarity is also involved. So, to get clarity we draw the diagram first, we approximately check the location, and based on our understanding we will derive the required whatever are the values. Okay. So, here let us say I take x axis, y axis. And where is this point 1, 2? It is in the first quadrant. So, let us say here is my point 1, 2 and it is given that it is one of the focus, one of the foci, and next this line is given as the nearest directrix. So, here if you check, both x intercept and y intercept of this point are negative. So, basically we will get one line here which is our directrix. This is the directrix. Now, this information is given and E equal to 3 is also given. Now, how do we get the others? So, if this is the nearest directrix and if this is the focus, the curve is going to have a shape like this. Okay. So, now if we want to find out the other characteristics, we have to predict the location of the other focus and other directrix. Now, that will come completely opposite to this. So, that means we need to extend this to another point which is let us say F2, and here the curve may be in this shape and directrix may be here. Okay. So, we may get one directrix here and the center of the entire curve will be somewhere here. So, this is our diagrammatic understanding. Based on this understanding, we will derive whatever is required. Now, first thing, what is asked? Focus is asked. So, to get the focus, let us try to get the distance between both foci. Distance between both foci is 2AE. So, for that E is already given. So, we need value of A. To get the value of A, what we try to do is, we try to take the distance between focus and this directrix. So, we know that focus and directrix are at a distance AE minus A by E. Using that, we will try to get the value of A. So, basically here AE minus A by E must be equal to the perpendicular distance of this point from this line. So, what is this perpendicular distance? Just put the point and get the distance. So, it is 3 into 1 plus 4 into 2 plus 9 divided by root of 3 square plus 4 square. Now, further if we simplify this, I can take A common. So, inside we will get E minus 1 by E, but value of E is already given. So, I can write here 3 minus 1 by 3. This must be equal to, what is the simplification here? 3 plus 9 is 12 plus 8 is 20. So, 20 by 5. So, now here 5 can get cancelled of course, and here if I simplify, A into I get 8 by 3 is equal to 20 by 5. Now, let us see what are the terms that may get cancelled. So, here we understand that 5 is getting cancelled and this 4 is also getting cancelled. So, we are basically getting A equal to 3 by 2. We got A, we got E also. So, what is AE? AE will become 9 by 2. What about A by E? A by E will become 1 by 2, right? A is 3 by 2 divided by 3 will give us 1 by 2. Okay. So, now using this we will try to get the question. So, to get F2, because we already know F1 and we know the distance between F1 and F2. So, we just need the direction of this line F1, F2. Now, to understand the direction in 2D geometry, what is the quantity that will give us direction? It is the slope. So, basically we are interested in tan theta of this, because already there is directrix and slope of directrix is already given as minus 3 by 4. We can get slope of this f1, f2 as 4 by 3. So, I will just explain it here. We have one point f1 here and this is our xy system, okay. And if there is another point f2, we are interested in finding this f2, but this is our starting point because we already know the coordinates of f1. So, to get f2, we need to travel in this direction and this direction is provided by tan theta. So, what is the tan theta that we got? We got it as 4 by 3 and we know the distance to be 9 by 2, which is r. So, if we apply this formula 1 plus r cos theta comma 2 plus r sin theta, we can get the point f2. But will tan theta give us the absolute direction? Will it give us the correct direction? No, of course not, because if you travel above, let us say in this direction or in this direction, tan theta will be same. That means slope is same. Basically tan theta, that slope, that will give you scalar, it will not give you the direction. So, vectorially if you need this direction, what is the thumb rule? This we have discussed in earlier lectures also. So, from this location, if we travel in this direction, we are getting f2. So, just check this direction. This direction is going towards the third quadrant. Even though the point f2 is not in third quadrant, even if it is not in third quadrant, because we are traveling in this direction which is extending towards third quadrant, we can take sin theta and cos theta to be negative. So, for this formula to be applied, we need to have clarity of cos theta and sin theta. For that, I have given you this idea of sign convention. So, here because tan theta is 4 by 3, I can get sin theta as 4 by 5, cos theta as 3 by 5, but because we are traveling in this direction, these two must carry minus signs. So, applying this, we will get the coordinates of f2, okay. So, this can be applied directly here. R is basically 9 by 2, cos theta is minus 3 by 5, comma 2 plus 9 by 2 into sin theta is minus 4 by 5. Just simplify this and get the coordinates. So, what do we get here? 10 minus 27, which is minus 17 by 10. Next, here it is 20 minus 36, right. So, which is same as minus 16 by 10. So, this way we can get the coordinates of the other vertex, okay. So, we got the other vertex using this idea. Now, I will calculate the directrix. So, to get directrix, again let us go back to the earlier setup. So, here we know that distance between both directrices is always 2a by e. We got a by e to be 1 by 2. So, 2 into a by e is basically 1. So, that means distance between these two parallel lines must be equal to 1. Now, we already know the equation of this blue line, we need the equation of red line. We can assume that this red line is going to be x plus y plus c is equal to 0, c being any constant. But because our setup is clear and it is correct, so this red line is coming towards the left. So, the red line will have more x and y intercept in magnitude. So, for the red line, the x intercept and y intercept will have higher magnitudes, but negative sign will be there. So, that we can derive based on the situation, that we can use based on the situation. So, let us first get some values of c. Because distance between these two lines must be equal to 1, we can say that 3x plus 4y plus c equal to 0, this is one directrix. The other directrix is 3x plus 4y plus 9 equal to 0. Because distance between these two lines is 1 unit, we can say that mod of c minus 9 divided by root of 3 square plus 4 square must be equal to 1. So, this will give us mod of c minus 9 to be equal to 5, which further will give us c equal to 9 plus minus 5. So, there are two values here, one is the 14, other is the 4. Now, which is our required value? Now, let us go back to the earlier discussion. Because red line is lying in the left side, it is going to have higher values in magnitude for x intercept and y intercept, but with negative sign. So, look at these two values. If I put 14 here and if I put 4 here, which will give me higher values of x and y intercepts? Of course, this 14 will give. So, 14 is accepted, 4 is rejected. So, this way we can find the required line using the distance between parallel lines. Okay. So, here if you understand, the main crux of the problem lies in understanding of the diagram. Suppose let us say if focus was below the line, below this blue line, then the entire setup may have been in the right side, then we may have to go upwards direction. So, for that also I have given you the method, because here if you have the clarity of these signs, then you can travel in any direction and get the points or lines. Okay. So, this way we can solve the problem. Come on, take a note of this. This page also. Also this page. Okay. So, now we will move on to the next question. Next, if the focus and directrix are already given, this is the focus and this is the directrix, latus rectum is also given. So, here basically length of latus rectum is given, and what is the conic? Question is about find the conic. Is it parabola? Is it ellipse? Is it hyperbola? Or is it rectangular hyperbola? So, now how do we proceed with this? Because this is open ended question, it can be ellipse or hyperbola. Because we are solving this in hyperbola, of course, the answer must be one of the hyperbolas, but in general if you face this question in the exam, how do you react? Okay. So, here this is the idea. Let us say there is this point focus here, okay, and there is let us say directrix here. Now, whether it is ellipse or hyperbola or parabola, the curve is going to bend towards the focus, that is always there. So, we will try to get this distance of the focus from this line, let us name this as D perpendicular. Okay. So, now if it is parabola, let us take one case. If it is parabola, then what must happen? This D perpendicular must be equal to 2a, and latus rectum for parabola is 4a. So, if latus rectum is already given and if we are expecting parabola, then this distance, perpendicular distance, must be equal to half of the latus rectum. Now, if it is not, then we will go for the ellipse or hyperbola. Okay. So, now then we will go for the second case. So, this is like algorithmic thinking. Okay. So, it is easy to check for parabola. So, we first hit parabola and then we will hit the ellipse or hyperbola. So, if it is not parabola, if it is ellipse or hyperbola, then what happens? Then the D perpendicular must be equal to AE minus A by E of mod, because in ellipse A by E is bigger than AE, in hyperbola AE is bigger than A by E, and then latus rectum must be equal to 2b square by A. So, this is the algorithmic thought process of this question. Now, how do we proceed? Let us get the perpendicular distance. So, here D perpendicular can be calculated directly like this. D perpendicular is equal to, we just have to put the point in this line. So, it becomes 2 minus minus 1 plus 1 divided by root of 1 square plus 1 square. So, what is this value? This value is going to be 4 by root 2, which is same as 2 root 2. Okay. So, that means if D perpendicular is 2 root 2, double of 2 root 2 is not giving us 8. So, it is definitely not parabola. Okay. Because perpendicular distance is not half of the latus rectum, it is not parabola, then that means it must be one of these two curves. So, let us explore here also. here we can get mod of e square minus 1 by e into a, mod of e square minus 1 by e into a must be equal to, what is the value? Value is 2 root 2, this we have derived earlier, and here 2b square by a must be equal to 8. Okay. So, here if I further simplify, b square by a must be equal to 4. So, now we may have to take two cases for this. Okay. So, one is the 1 minus e square by e, other is the e square minus 1 by e. So, let us take both of them and observe. So, let us take the first case. So, a into e square minus 1 by e must be equal to 2 root 2 and b square by a must be equal to 4 units. This means I am basically assuming that e is greater than 1, that is why I have removed mod and put e square minus 1. Now, further how do we simplify this? If I let us say supply one extra a here, then what happens here? It becomes a square into e square minus 1 becomes b square. So, basically this first equation becomes b square by a into 1 by e must be equal to 2 root 2, because b square by a is already given as 4. So, I can put 4 into 1 by e is equal to 2 root 2. So, this will get simplified to e being equal to root 2, which means if it is hyperbola, if it is hyperbola, it must be rectangular hyperbola, because e must be equal to root 2. So, but we did not take the other case. So, let me just explore the other case also. So, if I let us say take the other case, which is a into 1 minus e square by e, this is let us say equal to 2 root 2. So, again here if I supply one extra a, it becomes equal to b square by a into 1 by e equal to 2 root 2, and again we got b square by a to be equal to 4. So, here also by calculating, by taking the ratio of these two, we are getting e is equal to root 2 only, but this is rejected because we wrote this assuming that it is ellipse, but we got the value of e which is not for ellipse. So, this case is rejected. So, either way basically we are getting e is equal to root 2 only. So, for this curve we can say that the point lies on hyperbola, which is also rectangular hyperbola. Okay. So, the conic is rectangular hyperbola. So, I hope this algorithmic thinking is clear. So, this is how you should be thinking for most of the problems. Now, if teacher designs an algorithm, it is not necessarily your own algorithm, you need to design your own algorithm for your ease in problem solving. Okay. Come on, take a note of this. Okay. Can we proceed to the next page? Okay. So, now let us solve another problem. So, here one equation is given, we have to find foci, directrices, latus rectum and length of the latus rectum of this given curve. So, whenever you face a general equation, what is your approach? In ellipse we have already learned, but in hyperbola we are yet to learn, but still this question is there. So, in this your thought process shall be like this. Our first step is check xy term. Is xy term present or not present? If it is not present, it could be shifted hyperbola or shifted ellipse. Now, because when we face general equation, we do not know whether it is going to be ellipse or hyperbola directly. We have to check the parameters. because we are solving this in hyperbola, it has to be hyperbola, but in general that should be your approach. Now, second step is to check the coefficients of x square and y square. Are they positive? Are they negative? If one of them is negative and the other is positive, it could be hyperbola. Now, if coefficient of xy is equal to 0, it could be a shifted ellipse or hyperbola. If coefficient of xy is not 0, then we may have to handle it differently. In ellipse, we put r cos theta, r sin theta and we solved it, if you remember. But here we will learn the approach a little later. But because coefficient of xy term is here is 0, this must be shifted hyperbola because one of those coefficients is negative. So, now let us see how we solve this problem. So, how do we solve it? Collect all terms of x, collect all terms of y, try to apply completing square method. So, here if I let us say take 16 common from all x terms, what do I get? X square is here and from 32 I am taking 16 common. So, it becomes 2x minus from these two terms I am taking 9 common. So, minus 9 into y square plus 2y. Now, the constant I will put in the RHS. Now, I want to complete the squares here. So, think about a term which should be added to this first term so that it becomes a perfect square. We have to add 1 here so that it becomes x minus 1 whole square. So, that means how much did I actually add? I added 16. So, I have to balance it by adding the same value in the RHS. Now, again to get a perfect square here, I need to add 1. So, effectively I have added minus 9. So, to balance it I have to put minus 9 here. So, now this will give me 16 into x minus 1 whole square minus 9 into y plus 1 whole square is equal to what is the value here? 16 minus 9 is 7, 137 plus 7 is 144. Now, luckily 144 is 16 into 9. So, that means we can divide with 144. So, then what do we get? X minus 1 whole square by 9 minus y plus 1 whole square by 16 is equal to 1. Now, this has got converted into one of our shifted forms. We have seen shifted forms today. So, it got converted into this form. So, now we can just apply the same values, but we do not have to remember any of them. We can just go ahead with simple idea of A, E and B. Okay. So, here we are here. Now, what is the value of A here? A becomes equal to 3, B becomes equal to 4. Now, because A and B are known, we will get the value of E. E becomes equal to root of 1 plus B square by A square, which is same as root of 1 plus 16 by 9, which is 5 by 3. Okay. Now, what is AE? AE will become 3 into 5 by 3, which is same as 5. What is A by E? A by E will become 3 by 5 by 3, which is same as 9 by 5. So, we got all required setup. Now, let us try to derive all coordinates. Okay. So, let us take a diagram here. So, let us say we have this y axis, sorry, it is the conjugate axis, this is the transverse axis, and we have hyperbola this way, and here also we have hyperbola this way. Okay. Now, these are the vertices and this is the transverse axis. This is let us say focus F1, this is let us say focus F2, and here let us say we have one directrix and here let us say we have another directrix. Okay. So, how do we calculate the required parameters? We have to take one standard x axis y axis setup. So, let us assume that this is our x axis direction and this is our y axis direction. Okay. Now, because it is shifted version, how do we find the center? Whenever these two both terms become 0, for whatever are the values of x and y for which these two become 0, those will become the coordinates of center. So, when x is equal to 1, y is equal to minus 1, these two are becoming 0. So, that means this center will become 1 comma minus 1. This is 1 comma minus 1. Okay. So, we got the center. Now, from the center, how much distance we have to travel to get the focus? We have to travel a into e distance. What is the value of a here? A into e, it is already 5. So, from here we have to travel 5 units parallel to x axis. So, that means here only x coordinate will change, which is 6, and y coordinate will remain same. Similarly, to get f2 we have to travel 5 units left. So, that means it becomes 1 minus 5, which is minus 4, and y coordinate will remain same. What about vertex? We have to travel a units distance, value of a is 3. So, from center go 3 units right, so it becomes 4 comma minus 1, and similarly from center go 3 units left, then this becomes 1 minus 3, that means minus 2 comma minus 1. Similarly, what about these feet of directrices? This point, to get this point we have to travel a by e to the right side. What is a by e here? 9 by 5. So, it becomes 1 plus 9 by 5 comma minus 1. So, that means this becomes 14 by 5. So, equation of this directrix is going to be x equal to 14 by 5. Similarly, we have to travel 9 by 5 units to the left to get the other foot of the directrix. So, this point will become 1 minus 9 by 5 comma minus 1. So, that means this directrix will become x equal to minus 4 by 5. So, we got both foci, both vertices, we got the center, we got both directrices also. Now, what else is required? Ends of latus rectum. So, there are two latera recta here. So, we can get one end and basically we can duplicate it to get the other ends. So, here what are the coordinates? In general, it is AE comma B square by A. Those are the coordinates for the general setup. Now, for this setup we have to shift it by 1 unit right and minus 1 units up, that means 1 unit down. So, we just have to remove those, subtract those coordinates. So, what is AE? Basically it is 6, AE is 5, and because it is anyways on the latus rectum is parallel to y axis here. So, x coordinate must be same. So, I am just maintaining the same x coordinate here. What about y coordinate? To get that we need to understand b square by a. What is b square by a here? It is 16 by 3. So, here we have to go 16 by 3 units up. So, it becomes 16 by 3 minus 1. Similarly, here it becomes minus 16 by 3 minus 1. So, that is it. In similar lines we can also get the other ends of other latus rectum. So, this way we can solve this problem. So, here solving this will take simple understanding of the setup. So, if you have understood how we fixed the center, how we fixed vertices, how we derived focus, if you have understood those ideas, then you do not have to remember formulae for these. You can derive them on your own depending on the situation. Okay. But in this problem, the main step involved was converting the equation into standard form. After that, it becomes only understanding of the setup. Okay. Come on, make a note of this. This page also. Okay, so this is our last question. So, this gives you an example of how a parametric form can be different from the theta form. So, here it is given that these are x and y basically given in terms of a t parameter, third parameter, and we have to prove that this also represents the same hyperbola. So, how do we do that? Just check if this equation is satisfied or not. So, suppose let us say here if I take x by a whole square minus y by b whole square, I will basically get 1 by 4 into t plus 1 by t whole square minus t minus 1 by t whole square. If I simplify this, I will get 1. So that means this equation also represents parametric form of hyperbola. So this is not the only equation. So here there is one form that clearly represents the hyperbola. We can also design forms like this. Let us say x equal to a by root of m square minus 1 into m and y equal to b by root of m square minus 1. So this form also represents the same hyperbola, because when we eliminate m, we will get the same equation. So this example is actually an example of having multiple parametric forms of the given curve. So how many such parametric forms could be designed? There could be infinite parametric forms. But out of all these, we only prefer the theta because it has a significant geometric meaning. Okay. So with this problem, we will conclude today's lecture. We will meet again in the next lecture. We will start with the discussion on asymptotes and then we will proceed. So keep learning, always keep deriving on your own. Okay. So we will meet again in the next lecture. Until then, have a great learning day. Learning shall never stop.